Hey everybody, today's lesson is on functions and equations. We've been dealing quite a bit with equations, so we know what they are. Now we're just going to go a little further and talk about what functions are. And it says a function is a pairing of each number in a given set with exactly one number in another set. So we're going to be looking at something like this. Something like y equals 5x. Y equals 5x is a function. All right, and again, as our definition says, a function is when you pair one number from a given set with exactly one number from another set. Well, what's new to us today is this. All right, we haven't really dealt with equations that had two different variables, and we have an x and a y here. Well, that's what a function is talking about is, all right, if I have a whole bunch of x's, no matter what numbers they are, if I plug those numbers in place of x, I'll be able to solve this and get a specific y that goes with it. And that's what a function means. Kind of meaning, if I said here that x is 2, well, we'd be able to take that 2 and put it in place here and go 5 times 2, and we'd be able to figure out that it then pairs with 10. So what we're saying is that these two things go together. They are in relation, all right, in this function, that when x is 2, we get a very specific number for y, in this case 10, that goes with it. So we're kind of matching some x's with some y's, and they become a pair. Okay. If I change the x now, if I were to say that x equals 5, okay, well then that changes here. Now I'd be putting 5 in place of x, so this would become 5 times 5, and we would get that y equals 25. Okay, so in this case, that the 5 and the 25 would go together. These two things go together. All right, so what we're doing is we're coming up with partners here. We're pairs, all right? One specific x that gets matched with one specific y. That's its answer, okay? A couple terms that we're going to have to know here today. We have our x's, okay? X's are called our input numbers. Input numbers. They're called input numbers because those are the numbers, as I showed with the 2, that is being plugged into the equation. They are going into the equation, input numbers. And if my x's are my input numbers, then my y's, the answers that I get out as a result, are what we call our output numbers. Okay? So we have our input numbers and our output numbers. All right? X's are input numbers, y's are output numbers. We also have one other specific name for both of these. X's, also known as our input numbers, are also what we call the domain. Okay, so when you're hearing these problems that they're saying the domain is 0, 1, 2, 3, that means that your x's are going to be 0, 1, 2, 3. Okay, and y's, our output numbers, our answers, are what we call our range. Our answers range from this number to this number. If you get answers to the problem, those y's are going to be what are referred to as the range. Okay, let's go ahead and do a couple of these problems. Example 1 says evaluate y equals 5x1, x equals 7. So here's that same function, y equals 5x, and here's what they're telling us. They're telling us that x equals 7, and we know that x's are my input numbers, so that means that number has to be put into the problem. Okay, so when I plug it in, we get 5 times 7, which we can all figure out y equals 35, and that's all that they're asking us to do here. Now, they didn't ask us, but just to point out again, the 35 then will be considered an output number because that is the answer that we got that came out of the 7 going in. 7 went in as an input number, 35 came out as the output number or our result. Now, in the next couple examples, what they're going to do is instead of just asking to do this for one number, they're going to give us a bunch of numbers. They might give us 4 or 5 different x's. And for each x they give us, we're going to get a specific y as an answer that goes with it. So here we go. This will sound a little complicated, but we'll break it down for you. Example 2 says make an input-output table for the function y equals x minus 1. Using the domain 0, 1, 2, and 3, then state the range of the function. Okay. We'll get back to the input-output table. But the first thing that stands out to me is this. They're telling me the function that we're going to use is this y equals x minus 1. Y equals x minus 1. So that's the function that I'm going to use. It says then using the domain 0, 1, 2, and 3. Well, the domain is the x's. So they're telling me the x's that I'm going to use are going to be 0, 1, 2, and 3. So they're giving me 4 different x's. Then I'm going to have to, one at a time, put them in place of x And I'm going to get 4 different answers that come out. For each one of the x's I put in, I'm going to get a different answer that comes out. Okay? Now to do that, they do say make an input-output table. So here's what they're talking about. Okay, input-output table is this. We're going to make a little table, input and output, and we're going to make a little T table here where we're going to do this, where it's just going to look like a little T, all right, where the input numbers are our x's and the output numbers are our y's. So input-output table is the same thing as an XY table, and now they're telling me what the domain is. The domain is 0, 1, 2, and 3. So they're telling me those are going to be my x's. So in my table for the x's, I put 0, 1, 2, and 3. The y's I don't know yet. I have to actually figure out what the y's are, because what they're telling me now is one at a time, let's put these numbers in place of x. So if I go ahead and put the 0 in place of x, I'm going to get 0 minus 1. Okay, and we can do 0 minus 1. 0 minus 1 is negative 1. So that meant when I put 0 in place of x, its partner that came with it, the y, ended up being negative 1. So we put that answer back into our table. Okay, now I have to keep doing this. All right, so I'm going to rewrite this equation again. Okay, y equals x minus 1. But now I have to move on to the next number, which is this 1 right here. So now I put 1 in place of x. So y equals 1 minus 1. 1 minus 1, of course, is 0. So 0 goes into the table. And I just have to keep plugging away. I have to do this for every one. So y equals x minus 1. But now I'm on to this number 2. So I put 2 in place of x. 2 minus 1. And 2 minus 1 equals 1. So when x is 2, its partner, the y, is a 1. Y equals x minus 1. I have to do this one final time with my final number, which is a 3. So I end up getting 3 minus 1, which gives me 2. All right, so there's my input-output table. Okay, and then the final thing that says, then state the range of the function. Well, remember what we said range was. Range was just our y's. So in the table, my y's are negative 1, 0, 1, 2. So when it says state the range, you're really just stating what the answers are. Okay, the answers I got for the 4 numbers are negative 1, 0, 1, and 2. All right, let's do one more of these. I'm going to get you started, and then I'll turn you loose and let you do it on your own. Again, it says make an input-output table for the function y equals 2x plus 2. So y equals 2x plus 2. That's the function I'm going to use. Okay, using the domain negative 2, negative 1, 0, 1, and 2. So there are 5 numbers. That means I have to do this problem 5 times. Then state the range. So input-output table. Okay, well that's just my xy table. Instead of doing it horizontally this time, I'm going to choose to do it vertically. It really makes no difference which way you choose it. Okay, my x's. They're telling me the x's. The x's are these numbers, the domain. So I have to write that in. Negative 2, negative 1, 0, 1, and 2. And one at a time, I'm going to plug these 5 numbers into the equation for x, and then I'll solve and figure out what y goes with it. So let's start with our first one, the negative 2. If I plug negative 2 in place of x, then I need to solve it. Positive 2 times negative 2 is negative 4. I still have the plus 2, which then gives me that y is going to equal negative 2. So when x was negative 2, I got a y of negative 2. All right, we need to do it again. Y equals 2x plus 2. But this time I'm on to the next number, which is a negative 1. So I plug my negative 1 in for x. Okay, well 2 times negative 1 is negative 2. I still have to add that 2. So negative 2 plus 2 equals 0. So in this case, I get y equals 0. All right, so that's 2 times. This was 1 time that I did it. This was a second time. All right, I have 3 more times here. So y equals 2x plus 2. I'm on to my third number, which is a 0. Let's plug the 0 in. So this is 2 times 0 plus 2. Well, 2 times 0 is 0. 0 plus 2 is 2. So we get y equals 2. All right, did that one. Let's go again. Y equals 2x plus 2. This time we're on to the 1, so we plug the 1 in. 2 times 1 plus 2. Well, 2 times 1 is 2. 2 plus 2 gives me that y is going to be 4 this time. Okay. And then finally, so there's my fourth time. I got to do it one last time here. Y equals 2x plus 2. My last numbers are 2, so I plug that in. 2 times 2 plus 2. Well, 2 times 2 is 4 plus 2, which gives me this last one is that y equals 6. All right, so here's my xy table. Got that done. XY table. It says then state the range. Okay, I'm running out of room here, but I'm going to squeeze it in. My range is just rewriting these answers. -2, 0, 2, 4, and 6. Okay, and that's it. So make an input-output table. Did it. We plugged all our numbers in, the domain. We got the y's that came out, which is our range, and then we listed them. And that's it. That's our lesson for today.